Good morning, Year 9s. Welcome to today's lesson, which is another lesson where we're going to address some of the math skills needed in science. Okay. Maths is very important in science. In the physics exam final paper, it's worth about 30% of the marks, and in chemistry, it's worth about 20, and in biology, it's worth about 10. But don't be too concerned. The math skills required in science only cover a small range of skills. And analysis of previous papers with previous year groups have shown that the students that are prepared to put a bit of practice in and get these skills right have found that the actual maths questions in the final exams are a very easy way of picking up lots of marks very rapidly. So let's look at today's lesson. Today's lesson is about standard form, and standard form is sometimes called scientific notation. And the reason for that is because in science, you're often dealing with very big or very small numbers. And so in order to help you with that, here's a little video to explain that a bit further.
Meet Trevor. He's fluent in 7 languages: English, Klingon, Vulcan, Romulan, Bok, Shiribuk, and Tribble. Can you speak standard form, Trevor? Oh, you'll never get into space if you can't speak standard form. That's what they all speak up there. Numbers can be written out in what's called standard form. You might hear it being called scientific notation, but whatever it's called, it's very handy to know how to read and write it, especially as very big and very small numbers are often written out in standard form. Let me show you what I mean. 1,000. That's 1 and 3 zeros. Or, in standard form, 1 times 10 cubed. Now, what happens when I have the number 12,333? What do I do here? Well, in standard form, it's 1.2333 times 10 to the power of 4. Note where we place the decimal point, 4 places. You might wonder why bother with this lot. After all, how much trouble is it to write out a 5-digit number? Well, have a look at planet Earth. The mass of planet Earth is approximately 6 septillion kilograms. That's right, there are 24 zeros there. Or in standard form, 6 times 10 to the power of 24. Now do you see why it's handy? Now it's not just for big numbers, it works for small numbers too. Here's 0.0064. How can we write this in standard form? Well, it's 6.4 times 10 to the power of -3. Why 3? Well, how many places does the number 6 have to travel to get to the other side of the decimal point? Once you convert very big and very small numbers into standard form, it becomes easier to see their value at a glance. Practice changing them. Then practice changing the standard form into their totally tiny or super big numbers. 7.8 times 10 to the power -3 becomes 0.0078. And 6.78 times 10 to the power of 6 becomes 6,780,000. It helps to put your commas in the right place, just like any other language. Isn't that right, Trevor? Practice makes perfect. Yes.
So how do we write scientific notation, standard form? Well, it's always written in this style. A times 10 to the power of n, where a is a number between 1 and 10, it can never be a naught, and n is just a way of telling us how many places we've moved the decimal point. So for big numbers, we have to move the decimal point towards the left. And so if we look at this number here, look how many times I've had to move the decimal point. 1, 2, 3, 4, 5, 6, 7 times. So that number becomes 1.5 times 10 to the 7. For little numbers, we have to move the decimal point to the right. So look how many times we have to move the decimal point until we get it just behind a number. 1, 2, 3, 4 times. So that becomes 4.67 times 10 to the 4. Just to clear that up then, so for big numbers, we move the decimal point towards the right. And so this time I've had to move the decimal point 6 times. So that becomes 1 times 10 to the 6. 5 times, 4 times. Well, how many times am I moving it here? For 1,000, I have to move it a total of 3 times. So 1 times 10 to the 3. For 100, I have to move it 2 times. For 10, I only have to move it once to get it behind the first digit, and so it becomes 10 to the power 1. I don't have to move it any times for 1, and so I don't bother writing times 10 to the 0. If I'm going to go for small numbers, I have to start moving them to the right. For 0.1, I have to move it once to the right, so I've said -1. For 0.01, I've had to move it twice. And for 0.001, I've had to move it 3 times. Let's look at that in a little bit more detail. Here's a few you can do yourself. Okay, so 200. How do we do that? Well, we put the 2, and then how many times do we have to move the decimal place? Well, just twice. 230, to get it behind the 2, we get 2.3 times 10 to the 2. 300, well, we have to move the decimal place twice to get it just behind the 3, so it becomes 3 times 10 to the 2. 399, we have to again move it twice to get it just behind the 3, 3.99. 4 times 10 to the 2, twice again to get it just behind the 4, so it's 4.15. 500, 550, 5.5. This one, I have to move it 3 times, so it becomes 9.87 times 10 to the 3. Okay, this brings us on to the first of today's tasks. This task is described in your report as scientific notation standard demand. What that means is these are skills that everyone has to be able to perfect. Whether you're sitting foundation or whether you're sitting higher, these skills go up to level 5. And so everyone should have a go now at filling these in, which is the first part of the task is to put these standard form numbers back into their ordinary numbers. And then the second part of the task is doing the reverse, taking these ordinary numbers and putting into the standard form. Okay. So just to summarize, this is now standard demand. Here's a little task for you to do. This number here, 1 times 10 to the 100, is called a googol. How would I write 50 googols in standard form? Okay, we'll look at that. I can't just put 50 times 10 to the 100 because that's not standard form. I have to move the decimal place 1 more place. So it becomes 50 times 10 to the 101. Incidentally, this is a number that can't really exist because it's so big. Scientists have estimated that the number of particles in the universe are only 1 times 10 to the 81. So that number there is sort of an imaginary number, whereas this one here isn't an imaginary number. The dinosaurs were roaming the Earth. Well, that is 140 million years ago. How do we write that in standard form? Well, have a go. Give you a few seconds. Count the decimal places. And so your answer should be 1.4. And then we've moved it 1, 2, 3, 4, 5, 6, 7, 8 times. And so it's 1.4 times 10 to the 8. Okay. Right, the second task of today is described as higher demand. It's under the title multiplying and dividing big and small numbers. Higher demand is level 5 upwards. And so if you have a target of level 5 and upwards, you should attempt this. However, if you found the first part very easy and your target is less than level 5, then have a go at this task anyway. Remember to submit your answers to the teachers. Okay, so if we look at the first one, multiplying. So to multiply, we break the question down into 2 parts. The first part is we multiply the digits. Okay, so 5 times 10 to the 6 times 6 times 10 to the 5 works out to be a sum where we multiply the 5 by the 6. We then look at the powers and we add these 2 together. So that becomes 6 plus 5. Or to put it another way, 5 times 6 is 30. 6 plus 5 is 11. So it becomes 30 times 10 to 11. But that's not standard form, is it? So I have to do one little last operation. I have to move that decimal place 1 more way that way. And so it becomes 3 times 10 to the 12. Right, well, I've done the first example for you. 1.2 times 10 to the 3 times 1.2 times 10 to the 3. We look at that one there. That becomes 1.2 times 1.2 times 10 to the power of 3 plus 3. So 1.2 times 1.2 is 1.44. 3 plus 3 is 6, so it's 1.44 times 10 to the 3. The decimal place is just behind the first digit, so I don't have to do any more of that alteration. Right, you have a go at the rest, and again, submit your answers. And then the final task of the second task today is looking at how we divide numbers. And so here we have a little example. 6 times 10 to the 6 divided by 5 times 10 to the 5. Right, again, you break it into 2. You divide the 6 by the 5. 6 divided by 5. And then you take the powers away from each other. So 6 minus 5. So 6 divided by 5 is 1.2. 6 minus 5 is 1. And therefore, it's 1.2 times 10 to the 1. Again, luckily, we don't have to move that decimal point any further. It's in the right place. Here's the first example. 1.2 times 10 to the 3 divided by 1.2 times 10 to the 3. So I divide 1.2 by 1.2, and I take 3 away from 3, which gives me an answer of 1 times 10 to the 0, or if you remember, that's just 1. Right, well, that was a bit of an easy example, that one, wasn't it? So let's try this one down here. 7 times 10 to the 8 divided by 3.5 times 10 to the 2. So what do I have to do? I have to divide the 7 by the 3.5, and then I have to take the 8 away from the 2. And when I do that, 7 divided by 5 is 2, 8 divided by 8 minus 2 is 6, and therefore it's 2 times 10 to the 6. Right, again, have a go at finishing that sheet and submitting that work to your teacher. Any questions, feel free to ask through the comments section. Have a good day. Finally, if any of you have managed to understand all this, then here's a last little plenary task for you. And this combines this lesson and your previous lesson on standard units. So what is this in standard units and also in standard form? Right, well, the standard unit for power is the watt. And this big M here stands for mega, which is 1,000,000. So in order to answer this one, we are going to have to write it as watts. And in order to do that, then it's going to be 3.4 times, now 1,000,000 has got 6 noughts behind it. So it's times 10 to the 6 watts. Okay, 3.4 times 10 to the 6 watts. Look at the second one here. 3 millimeters. Well, the standard unit for length is the meter, and a milli is 1,000th of a meter. So 3 times 10, and then 1,000th is minus 3 meters. And therefore, that concludes everything we have to study today. Okay.